Hello and welcome to another HiQ Tech Talk. My name is Johan Sanneblad and I work with innovation projects at HiQ Sweden. If you watched Apple's latest keynote or just happened to browse across Apple's website, the major new feature of all new iPhones this year seems to be 5G. 5G was introduced as a new era for the iPhone, and Apple spent nearly 10 minutes of the keynote explaining how fast 5G can be and how it can provide things like super low latencies, so experiences like multiplayer gaming feels like they are happening in near real time. But is this really what you can expect if you buy a new phone with 5G today? Unfortunately, the answer is no if you live in a country outside of South Korea or the United States. But to understand why it is so, you need to know a bit more about 5G and why the actual transition to 5G takes such a long time. 5G sounds simple, but it's actually a quite complex standard. For example, did you know that 5G has 3 different speeds, also called frequency bands, and that we here in Sweden only get 2 of those? And did you know that most 5G networks initially won't have much faster response times, also called latency, than the 4G networks, despite promises of near real-time performance? In this tech talk, I will explain everything you need to know about 5G and how 5G will affect you as a company and end user. So, what is it that makes 5G so much different from 4G? If you search on Wikipedia, you find out that 5G uses radio waves with much higher frequency than previous cellular networks. The higher the frequency, the higher the potential speed. But exactly how much higher speed is 5G compared to 4G? The answer is, it depends. The absolutely highest speed of 5G is achieved using something called mmWave. mmWave is short for millimeter wave, which are radio waves that have so high frequency that their wavelength can be measured in millimeters. Now, why are we talking millimeters here when the main difference between 4G and 5G was the frequency? When it comes to radio signals, the wavelength is inversely proportional to the frequency. The higher the frequency, the shorter the wavelength. For example, 30 kHz, which is a low frequency, has a wavelength of 10 kilometers, while 30 GHz, a high frequency, has a wavelength of only 10 millimeters. With mmWave operating above 25 GHz, 5G can achieve amazing speeds, up to several gigabits per second. In theory, this is up to 10 times faster than the current latest, fastest 4G networks. The problem with mmWave is that, due to its high frequency, the signals have trouble passing through materials such as walls and windows. This means that mmWave installation would typically be done at dense city centers and environments such as sports stadiums and convention centers. In several countries, such as the United States and South Korea, mmWave has already been rolled out in some areas. Now, how fast is mmWave in practice? The latest iPhone 12 actually has support for mmWave, which can be spotted by its antenna just below the power button. A company called SpeedSmart, who develops an iPhone app with the same name, has already collected actual speed data from the latest 5G iPhones and have measured speeds up to 2000 megabit in supported areas. And that's crazy fast. Now, if you live outside the US, the iPhone 12 ships without mmWave, and you will not have that plastic mmWave antenna below the power button, and you will definitely not have any gigabit speeds on your cellular connection. The simple reason is that governments have still not approved the use of these high frequencies, and taking Sweden as an example, mmWave is scheduled for introduction in the 3 largest cities in the year 2025, with the rest of the major cities following in 2026. Before that, we will not have any mmWave in Sweden, which means Wi-Fi will continue to be the main way of high-speed connectivity for at least 5 years ahead. So, is this a problem? In some ways, yes. The main advantage with mmWave over Wi-Fi is that it has much better handover performance between access points. If you have a device such as a drone or a mobile phone and you move from one cell to another, there needs to be a handover. And these mechanisms are much better performed by a cellular network than by Wi-Fi. For event arenas where you are mostly stationary, maybe this won't be a big issue, but the promise of 5G as an enabler for augmented reality services means that many countries, such as Sweden, will have to wait for many years before mmWave is deployed, before we can start exploring the opportunities mmWave gives us. So what kind of 5G do we get in countries outside the USA and South Korea, like here in Sweden? In addition to the superfast mmWave 5G, the 5G specification also includes something often referred to as sub-6 GHz 5G. And this in turn consists of two separate specifications: low-band 5G operating around 600 to 700 MHz and mid-band 5G operating at 2.3 to 3.7 GHz. The low-band 5G has speeds that are similar to what we have in our 4G networks today, with similar coverage. This is the 5G that is rolled out mostly across the United States, with typical speeds around 30 to 50 megabits per second, according to a recent study by RootMetrics, which is slightly faster than what we have today with 4G. Mid-band 5G has speeds between 100 to 900 megabits per second, and in South Korea, the average transfer speed over 5G is actually right now around 650 megabits, according to a Ministry of Science and ICT. Here in Sweden, there will shortly be an auction where up to 3 companies can bid for the highest mid-speed 5G at 3.5 GHz. If there are more than 3 companies that want to deploy 5G mid-speed, other companies have to use the slower 2.3 GHz frequency. Now, before this action is held, no operator can roll out 5G in Sweden, except for limited test usage in specific locations, such as central Stockholm and central Göteborg. If you happen to have an iPhone 12 today, you can actually test mid-speed 5G by going to the city center, and you should have up to 800 megabit download speeds. This example was taken in central Göteborg using an iPhone 12. The plan in Sweden was to finish the 5G mid-speed auction in early November 2020, but due to uncertainty if operators could continue to use hardware from Huawei or not, the auction was postponed until further notice. The main reason why this would impose problems for the operators is something called NSA, non-standalone 5G. You see, right now, most carriers that have rolled out and are rolling out 5G are using a technique called non-standalone 5G. What this means is that even if you use a 5G device, all communication and control is still handled over a 4G network. Only the data itself is running over 5G. The device itself connects with multiple radios on multiple frequencies, but the timing is limited by the older 4G standard. This is why even the fastest 5G networks today have latencies around 20 milliseconds, which is far from the promised figures of 5G, just a few milliseconds. Many operators in Sweden use Huawei 4G hardware specifically for communication and control of 5G devices. And if there was a requirement for them to replace all Huawei devices before they could roll out their 5G networks, it would basically mean that they would have to replace their entire cellular infrastructure all over Sweden. And this is clearly not what they intended, at least not within a few years. So, when will operators switch over completely to a 5G infrastructure that also uses 5G for communication and control? My guess is that it will probably not happen before mmWave is launched on a large scale. And this means that we have to continue another 5 years or so with high latency cellular networks even over the 5G network. So, there have been quite lots of information in this tech talk, and I hope at least some parts of it made sense. To summarize, first, the fastest 5G speeds, mmWave, which is already rolled out in South Korea and USA, will not be available in many countries such as Sweden for at least 5 years. This is why the iPhone 12 series only support mmWave for devices sold in the USA. This means that you will not be able to experience any of the newer services that support gigabit speeds over 5G anytime soon if you live in Sweden. Mid-speed 5G, which is faster than 4G, is already rolled out in the USA and will be slowly rolled out in Sweden once the Spectrum auction has been held. But expect it to take a few years before we have good coverage, and the difference will be around double the download rate in urban areas, if you have a good connection. To achieve the low latencies that the 5G network is capable of, operators need to do a full transition to a dedicated 5G network where they no longer piggyback on the 4G infrastructure. How long this will take is free for anyone to guess, but my guess is that it will take up to 5 years in Sweden. This means that latencies will be around the same for 5G as for 4G for many years ahead. If you have a company that works with large wireless installation and events, you have to continue using Wi-Fi for at least 5 years here in Sweden. Similarly, if you're an app developer, don't expect that gigabit speeds over 5G will be available anytime soon. In many countries, it's still many years to go before mmWave is rolled out. If you plan to develop services that depend on low latencies over cellular networks, you will also probably have to wait several years for operators to transition their current 4G infrastructure into 5G. And this will also probably take up to 5 years here in Sweden. If you buy a phone today, don't buy it simply because it has 5G. I guess the situation is different if you live in South Korea or in some metropolitan area in the United States. But here in Sweden it will take at least 5 years before we have high-speed 5G with low latency rollout. Before then, the best you can hope for is slightly higher download speeds, which will probably start happening next year once the mid-speed 5G starts rolling out on a national level. That was all for me today, and I hope you learned something. On my next Tech Talk, I will talk about the new Apple M1 laptops, which we are currently using in a research project for Volvo Cars. I will show you hands-on how we use them, and I will explain why they are a really big deal if you're a tech company working with Apple technology today. Until then, goodbye.